Hey guys, today we're actually going to be going through two different lessons, both that talk about the different ways that we categorize elements on the periodic table. So let's get into it. Okay, so this lesson is titled The Periodic Table of Elements, which we've already learned how to read. And again, like I said, today we're going to talk about how we categorize the elements on the periodic table. So one of the ways we do that is metals and nonmetals. And you do need to know the characteristics of both of those groups, as well as where we would find them on the periodic table. We're also going to briefly touch on the difference between elements and compounds and kind of the different categories of that. So an element is a pure substance which cannot be physically or chemically broken down into simpler chemical substances. The only way to break down an element is through nuclear reactions, not chemical reactions, and you certainly can't just like cut one apart. All the elements that we know of are located on the periodic table, though the one we have hanging in my classroom doesn't have all of them because it's old and we have discovered new elements since then. And we're constantly discovering new elements. I shouldn't say constantly, but scientists are definitely still working on it and new elements are still being discovered. If something's not on the periodic table, it's not an element. It's probably a compound or a molecule instead. So for example, water can still be a pure substance, but it can be chemically broken down into hydrogen and oxygen. So water is not a pure substance, and you won't find it on the periodic table. The element symbol is just the letter or letters that we use to represent an element on the periodic table. It's usually one or two letters, sometimes based on its name in English, other times based on its name in Latin. Okay, compounds are pure substances that are made up of two or more elements that are chemically joined together. So for example, if I had sodium and I had some chlorine, those are both elements. I can chemically join those together to make the compound salt. Another example is hydrogen and oxygen can be chemically joined to form water or to form hydrogen peroxide, depending on your ratio of hydrogen and oxygen. Elements are the building blocks for all substances, all molecules, all compounds. Everything around us is either an element or elements are the building blocks for it. So for our pure substances, our elements can be either individual atoms, like a neon atom floating around, or we can have elemental molecules as well, like oxygen or nitrogen, which show up as O2 or N2. And then you can also have compounds, which can be molecules like H2O, or ions. The difference between these two different types of molecules is just elemental molecules only have one type of element in them. This type of molecule has at least two different types of elements in it. Okay, and by the way, we are going to spend more time talking about these different types of molecules and the bonds that form and stuff like that. Okay, so metals and nonmetals, two really important categories on the periodic table. Super important that you can just look at an element where it is and know if it's a metal or a nonmetal, because that affects what type of compound it can make. So metals are located on the left and center of the periodic table. They are always shiny, though sometimes you have to like scrape off the outside layer to see that they're shiny because they oxidize or kind of like rust in the air if they react with oxygen. But they will all be shiny if freshly cut. They also tend to be malleable and ductile, meaning that we can squish them into thin sheets. That's malleable and ductile, pull them into a wire. They also tend to conduct both heat and electricity really well. So these are just a whole bunch of examples around the outside here. Then we also have our nonmetals, which are found on the upper right corner of the periodic table. They're mostly gases and powdery solids, except for bromine, which is the only liquid nonmetal. They tend to be quite dull in appearance. They're not shiny. They also tend to be brittle, so they're not ductile or malleable. If you try and squish them or pull them into a cord, they will just crumble. And they are usually not very good conductors of heat or electricity, with the exception of carbon. So they tend to be fairly good insulators. There is also a third category called metalloids, which have properties of both metals and nonmetals. They're located along the staircase between the periodic tables. Most of the things that are touching the staircase are metalloids, though aluminum is an exception to that. Aluminum is a metal. So this is kind of what that looks like. So we have in the pink color here our metals. The green is our nonmetals. Even though it has aluminum as a metalloid here, that's not really true. We consider aluminum a metal. And then hydrogen, it does also have properties of both, but we don't really, it sometimes acts like a metal, but it is a non-metal. It's a gas, so it's definitely not a metal. Gases aren't metals, metals aren't gases. Okay, we are now going to switch over to the other lesson that talks about other ways of categorizing elements. Okay, the second lesson that we're going to look at here is different patterns on the periodic table. So we're going to be going over essentially some of the different families or groups on the periodic table. First of all, Dmitri Mendeleev was the kind of like the father of the periodic table of elements. He collected information on the properties of all of the elements that were known at the time, which was 63 of them. He then ordered all of the elements by mass and then grouped them based on their physical and chemical properties, which is how we arrange the periodic table to this day. When he did that, he did notice that there was empty spaces on his periodic table, and he predicted that we would discover elements that fit into those spaces. And he was right. And now we have like 120 elements-ish. So like I said, the periodic table of elements is arranged based on the chemical and physical properties of all of the different elements. So just by knowing where an element is on the periodic table, you can predict what its properties will be, even if you don't actually know anything about that element. And vice versa. If you know the properties of an element, you can predict where it would fit on the periodic table. So there are different chemical families on the periodic table, which is a family is just like a vertical row. We are going to learn about the chemical families in rows 1, 2, and then 17 and 18, also sometimes called 7 and 8. So in group 1, that is the very first vertical column on the periodic table, that is the alkali metals. So they contain lithium, sodium, potassium, cesium, stuff like that. They are all very soft, they're shiny because they're metals, and they have very low densities. You can actually see in this picture up here that lithium is floating, and this would be in oil, not in water. They actually react with water. They are highly reactive. They're usually not found on their own in nature because they would have reacted with something. They would have combined with another element to form a compound. And like I said, they even react with water. If you put these in water, they start to fizzle, they start to produce hydrogen gas, and many of them catch on fire and explode. They have to be stored in oil, which is what is being shown in these pictures up here, because they'll also react just with the air. And if it's humid, they can actually explode based on contact with the water vapor in the air. So they're stored in oil. Then we have the alkaline earth metals in group 2, which is just the second vertical column. They're also very shiny. They're harder than group 1 metals. They're also less reactive than group 1 metals. They can just be stored in the air, for instance. And if you burn them, they tend to produce really bright, colorful flames. They tend to be used in fireworks because they're so nice and colorful. Then we're going to go to the other side of the periodic table to group 17, which is the halogens. In this group, fluorine and chlorine are both gases at room temperature. Bromine is the one that is liquid. And iodine and astatine are both solids at room temperature. These are also highly reactive and rarely found just by themselves as like a single atom. They do tend to react with themselves. So for example, fluorine, bromine, iodine, chlorine, all of those you wouldn't just find a single atom of, but you would find like 2 bromines or 2 chlorines or 2 fluorines stuck to one another, floating around in an elemental molecule form. These also tend to be poisonous or toxic. Like chlorine gas was used as like a chemical warfare type thing. You also use it in pools in lower concentrations to like kill algae and stuff like that. Iodine can be used as a disinfectant, that sort of thing. So can bromine. Some places actually use bromine in their pools instead of chlorine because it doesn't smell the same way. And halogens tend to burn very brightly, though not colorfully the way the alkaline earth metals are. They're just very bright. Think like a halogen light bulb. And then the last family that we're going to talk about is the noble gases. It is the vertical column of group 18. And they are very stable. It is incredibly difficult to get them to react. They're often considered unreactive. They're colorless, they're odorless, they're tasteless. They do burn very brightly if you put electricity through them. So if you run an electric current through them, that is how like neon signs work. And they'll all burn different colors. They're also non-toxic, which is good since you can't see them or smell them. I do want to briefly talk about hydrogen here. It's a bit of a lone wolf in that it doesn't really belong to any family. I know, sad. It's in the same vertical column as the alkali metals, but it is not an alkali metal. It's not a metal at all. It's placed there because it sometimes acts like a group 1 element when it's like bonding, and its chemical structure, its atomic structure kind of looks like that. However, it's a gas. It is not a metal, okay? If you put enough pressure on it, sometimes it can behave like a metal and form like alloys and stuff, but under normal atmospheric room type environmental factors, it's nothing like a metal. Okay, there's also something called periodic trends. So each row on the periodic table is called a period. And usually there's kind of like a pattern of reactivity to that, but you don't really need to know that. At the bottom there, don't worry about that homework. At the bottom there, in the orange, are just different periodic tables that you can use, and they tell you different properties of different elements and stuff like that. Okay, that is it for today's lesson.